Every day, millions of people ask artificial intelligence to write emails, generate images, solve complex problems, and even create software. It feels almost magical, as if intelligence itself now lives inside our machines. But behind every AI breakthrough lies something most people never see. Endless rows of humming servers, vast data centers consuming enormous amounts of electricity. And inside those machines, specialized computer chips performing trillions of calculations every second. Across much of today's AI industry, those calculations are powered by graphics processors originally designed for an entirely different purpose.
For decades, one company quietly refined those processors, while the world mostly knew it for gaming. Long before artificial intelligence became a global race, it was building many of the tools that would help make that race possible. This is the hidden empire of NVIDIA.
In 1993, 3 engineers founded NVIDIA with a simple ambition: to make computer graphics faster and more realistic. The personal computer industry was expanding rapidly. Gamers wanted richer worlds, smoother animation, and increasingly realistic visuals. NVIDIA focused on building graphics processors, specialized chips designed to handle visual computing far more efficiently than traditional processors. Success was anything but certain. Competition was fierce, technology evolved at a relentless pace, and every new product carried enormous financial risk. More than once, the company's future depended on whether its next generation of chips would succeed. Yet while much of the industry concentrated on better graphics, NVIDIA's engineers began asking a different question. What else could these processors become capable of? That question would shape not only NVIDIA's future, but eventually the future of computing itself. Most computers rely on a central processing unit, or CPU. Think of it as a highly skilled worker, capable of handling a few complex tasks with remarkable speed. A graphics processing unit, a GPU, works differently. Instead of solving one difficult problem at a time, it can solve thousands of smaller problems simultaneously. Imagine asking one chef to prepare a banquet for 1,000 guests. It would take hours. Now imagine 1,000 chefs, each preparing a single plate simultaneously. The meal is finished dramatically faster. NVIDIA believed that this style of parallel computing could solve problems far beyond computer graphics. In 2006, the company introduced CUDA, a software platform that allowed developers to use GPUs for scientific computing, engineering simulations, and eventually artificial intelligence. At first, many people saw little reason to change the way software was written. Building an ecosystem around parallel computing required years of investment, long before there was widespread demand. But while much of the industry remained focused on graphics performance, NVIDIA was investing in capabilities that would later become essential for modern AI. Then, in 2012, a breakthrough from the world of academic research revealed just how valuable that long-term investment had become. For years, NVIDIA's investment in parallel computing remained largely within the worlds of scientific research, engineering, and high-performance computing. Then in 2012, something remarkable happened. A team of researchers entered the ImageNet competition with a deep learning model called AlexNet. Instead of relying only on traditional processors, they trained their neural network using NVIDIA GPUs. The results surprised much of the AI research community. AlexNet achieved a dramatic improvement in image recognition accuracy, demonstrating that graphics processors could accelerate deep learning at an entirely new scale. It wasn't the beginning of artificial intelligence, but it became one of the moments that convinced researchers around the world that deep learning could solve increasingly complex problems. Suddenly, GPUs were no longer seen as hardware built only for games. They had become one of the most important engines behind modern AI.
Revolutionary technology is rarely defined by hardware alone. Its true strength often comes from the ecosystem built around it. Years before artificial intelligence entered the mainstream, NVIDIA invested heavily in CUDA, a software platform that allowed developers to harness the power of GPUs for far more than computer graphics. Researchers adopted it. Universities began teaching it. Developers built tools, libraries, and frameworks around it. With every new project, the ecosystem became stronger. With every new developer, the platform became more valuable. By the time artificial intelligence entered the global spotlight, NVIDIA wasn't simply offering faster processors. It had spent years building an environment that many researchers and organizations already trusted. That long-term investment became one of the company's greatest competitive strengths.
Artificial intelligence had been advancing quietly for decades. But in late 2022, generative AI entered everyday life. Millions of people began using tools capable of writing, translating, generating images, answering questions, and assisting with software development. Businesses accelerated their AI strategies. Investors increased funding. Technology companies expanded their computing infrastructure.
Governments began recognizing artificial intelligence as a strategic priority. Demand for advanced computing grew at a pace few had anticipated. Data centers expanded across the world. Orders for high-performance AI processors surged. Years of patient investment suddenly met an unprecedented wave of global demand. NVIDIA hadn't created the world's fascination with artificial intelligence, but many of the technologies it had spent decades developing suddenly became essential to powering that transformation.
Yet one challenge remained. Building those advanced chips would prove far more difficult than designing them. By now, one thing had become clear. Artificial intelligence was no longer limited by ideas. It was limited by something far more tangible: compute. Every breakthrough model, every scientific discovery, and every intelligent system ultimately depended on one physical object: the semiconductor chip. Designing a powerful GPU was only the beginning. Manufacturing one required extraordinary precision. Billions of microscopic transistors had to be etched onto silicon with astonishing accuracy, inside some of the most advanced factories ever built. Every silicon wafer represented years of research, billions of dollars in investment, and engineering at an almost unimaginable scale. Long before an AI model could answer a question, its journey began here, inside ultra-clean facilities where even the smallest imperfection could determine success or failure. That journey led to Taiwan. Despite its relatively small size, the island became home to the world's most advanced semiconductor manufacturing. Companies like TSMC transformed complex chip designs into physical reality, producing the processors that power today's most demanding AI systems.
NVIDIA and TSMC formed a partnership that quietly reshaped the technology industry. While NVIDIA pushed the boundaries of chip design, TSMC mastered the extraordinary challenge of manufacturing those designs at scale. Together, they built the foundation upon which the modern AI revolution would stand. From Taiwan, millions of advanced processors began an invisible journey across oceans, through ports, cargo aircraft, and global logistics networks, before arriving inside hyperscale data centers around the world. Behind every AI breakthrough stood a supply chain operating with remarkable precision. As artificial intelligence accelerated, advanced semiconductors became far more than commercial products.
Governments introduced export controls, technology restrictions, and massive investments in domestic manufacturing, recognizing that leadership in AI would increasingly depend on access to advanced compute. The race for artificial intelligence was no longer defined only by better algorithms. It had become a race to secure manufacturing capacity, infrastructure, and the computational power that would shape the next generation of technology.
Today, artificial intelligence extends far beyond chatbots and image generation. It is accelerating scientific discovery, assisting medical research, improving industrial automation, and helping solve problems that were once considered impossible. Every new generation of AI demands dramatically more computational power than the one before it. As models continue to grow in scale and capability, the infrastructure supporting them must evolve just as rapidly. Around the world, hyperscale data centers have become the factories of the digital age. Quietly operating behind the scenes, they provide the computational foundation that powers research laboratories, cloud services, autonomous systems, and the intelligent technologies millions of people now use every day. In many ways, compute is becoming as essential to the modern economy as electricity and the internet once were. The nations and companies capable of building this infrastructure will help shape the future of artificial intelligence for decades to come. NVIDIA's greatest advantage was never a single chip. It was the ecosystem surrounding those chips. CUDA, researchers, developers, cloud providers, and advanced manufacturing came together to create a platform that competitors could not easily replicate. That advantage was built patiently over decades, not overnight. Looking back, NVIDIA's rise appears almost inevitable. In reality, it was the result of countless decisions made years before the world understood where artificial intelligence was heading. While others focused on the market of today, NVIDIA quietly prepared for the demands of tomorrow. If you enjoyed this story and want to explore the hidden forces shaping technology, business, and the future of our world, consider subscribing to Hidden Ledger. Every episode uncovers the ideas, decisions, and innovations that quietly change history, one story at a time. Thank you for watching, and I'll see you in the next episode.